Earthquakes occur by surprise to most people. They're often not prepared for them. This is challenging for earthquake scientists because we do know generally where large earthquakes are going to occur around the globe, and we're not able to provide the kind of earthquake prediction, like weather prediction, that some might hope for. But nonetheless, we are able to recognize areas that are prone to earthquakes, and certainly we encourage ourselves to do everything we can to prepare for these events.
Our data, well, they primarily come from GPS satellites. Those are 20,000 kilometers above us right now. They circle the Earth and they beam down signals which we can use to measure the deformation of the Earth very, very precisely. So this is an example of the type of data that we primarily use to understand the earthquake cycle. And this is what we call a GPS time series. What we can see here are three distinct stages of the earthquake cycle. The first stage is characterized by this relatively gently sloping blue line here. This continues for about 8 years until suddenly the catastrophe hits. The catastrophe is nothing short of the occurrence of the earthquake itself. And on that one day, position of this GPS station changes by approximately 1 meter. This jump here, this sharp jump in this time series, is the signature of an earthquake occurring, and this is how GPS records it. With these measurements in hand, then we build large computer models of how the Earth's surface moves and deforms. And then once we have these, we can kind of turn the crank on the computer and see what it predicts in terms of present day and future behavior on faults. Here we're looking at about 1,800 GPS velocities, that is the deformation in between large earthquakes, recorded in Western North America. What we've done is we've taken these velocities, we've put them through this computer code which incorporates the physics of the earthquake cycle with tectonic rotations, and then we ask how well can we explain them. So here are the observations in blue. I'm going to take the blue ones off, and then I'm going to show you what the model predictions are in red. And we see almost all of the same features are replicated by this model here, suggesting that the model that we've built here, which incorporates both earthquake cycle and tectonic processes, can explain the bulk behavior of the system very, very well. The fact that these two look so similar lets us know we're having a good day. But with more and more technologies, we are getting better at localizing these signals, that is, the location of future earthquakes in both space and time. And this is a step towards earthquake prediction.